Thank you.
So I'll define myself as one of the chief geeks, and that can be interpreted in various ways. But my actual role formally is I run all of engineering and manufacturing for our systems and technology business. So this includes all of the plants where we do our semiconductor research, our semiconductor process engineering, to the plants that produce semiconductors, to the people who design microprocessors, to the folks who design computers, who build computers, who test computers, and then we ship the computers and storage systems out the door. We don't do commodity silicon.
There's no more x86 anymore?
No,
as part
we
of the
don't do
business?
commodity silicon. When we build what you're calling commodity, or rather I'll use the word volume systems.
Okay.
We tend to procure the silicon from those who do produce it,
Yeah.
be it Intel and others.
Sure.
And we do then design, and we hope that we do get some unique IP in the way we design these systems.
Sure.
And then we do supply those to our clients.
How do you differentiate when that same base is the same across vendors XYZ?
Absolutely. So you'll say, are all x86 systems running Linux the same, or is there a difference? So at a hardware differentiation level, you talk about, well, how much does the hardware scale? Does it scale to a few threads and a couple of cores, or does it scale up to tens or hundreds of threads and that many cores? And you would ask, well, why does that matter? It matters because how you put the systems together in terms of how they connect to memory. So what's the aggregate memory bandwidth from the memory system that's on the computer to the compute, which is the cores, is important. And that does vary depending upon the vendor and their level of design expertise. Because in order to get hundreds of gigabits as aggregate bandwidth, you do need that level of design expertise.
Sure.
In terms of memory controllers, in terms of signal integrity, in terms of resilience, and so forth. Then you turn into, is somebody running these systems 24/7? How resilient is the memory system?
Yeah.
Can you tolerate some errors, or is every single error going to put you out of business?
Right.
And when you think about these systems that run at these kind of clock speeds and these kinds of frequencies and that kind of density of computing, you are going to get, I'll call it, an error a day or an error a week.
Sure.
So if you're resilient to that, you can look past that and keep continuing operation. But if you're not resilient to that, it'll bring you down. And, you get your blue screen of death on your laptop, you don't care, you reboot and you go on.
Right.
You get a blue screen of death on a server that's perhaps serving a client, you might have just lost a transaction.
When you're building systems, how do you balance the needs of these multiple operating systems, whatever they might be?
Great question. So let's take Power as an example, as a hardware platform.
Sure.
On top of Power, we support AIX, which is a Unix
Sure.
driver. We support i5 OS, which is the current generation of what used to be called the AS400, and we support Linux. And if you look at them, they all, I call it, to serve different market needs. If you already have a set of applications running on what was AS400 or i5 OS, and there is no particular economic benefit to you to go spend the energy to port them onto something else, because that takes time, effort, energy, testing, and some risk, you'll keep running that OS. If you want to run a highly scale-up system, you want the kind of resilience that AIX can provide, you want the kind of journal file system integrity, etc., you'll run things in AIX. And then you talk about Linux. So if I look now at market facts, right, because I don't want to do it based on just my desire. I got to do it based on what the market wants.
Sure.
Over the last 5 years, Linux market share has increased by 10 points. It's gone from 13% to 23%. Right? And that's not just our data. That's, IDC, Gartner, all the folks who do these measurements do that. So in order to participate in that growth, if we can then support Linux running on Power, it allows clients who want to run Linux a choice, and they can then get a more resilient platform that goes against it.
Sure.
So you balance it based on what the market wants. So since there is growth, this looks like a couple of points a year of growth on the Linux side, we're going to invest heavily on Linux in order to support those on our platforms, so that their clients get the choice based on their needs of which platform they can put underneath their Linux applications. Well, for us, look, we've got to service the client.
Sure.
I'd say in most cases the client has some idea of what they want. Then we're going to compete against other vendors, not in our own product portfolio.
Sure.
So I'll compete with HP and Dell and Oracle for that footprint, right? And they have their own unique flavors, right? And
Sure.
Oracle supports their own, I'll call it, fragmented version of Linux.
Yeah.
And then there is HP, who has their own versions, including of ARM processors, not just x86 or
Sure.
or RISC in their case. So the question comes in: what does the client want? What the client wants is often dictated by the needs of the application, etc.
Yeah.
Then you come in and say, my engineering, combination of both OS and platform, serves your need better. And that's what you got to prove to the client, both at a technical level and at an economic level. So, for example, if you take Power, I'll walk in and say, look, if you're really running a enterprise application, we can give you 30% better performance. We can give you twice the density. We can give you 18% lower labor cost if you want to run Linux on Power as compared to Linux on, let's say, x86. On the other hand, if somebody says, I got very lightly loaded stuff, I can't worry about density, I can't worry about packing it together, what I just talked about Power may not be relevant.
Sure.
Right? But a lot of people do care about the density and about the labor cost.
Sure. Where do you see the gap or the difference right now between, say, AIX and Linux for customer engagement?
I think a lot of it lies, first of all, I come to protection of investment. So some people estimate, so I'll go back all the way to ZOS for a moment.
Yeah.
Some people estimate that there is $1 trillion worth in today's labor cost of code written for ZOS. When you think about all the based on things like Kix and COBOL and
Sure.
IMS and the database, the DB2 or the mainframe, etc. So you could say, could I run that on another platform? First is the technology argument. Okay, do I have the resilience? Do I have the scale? Do I have the availability, etc.? Sometimes the answer is actually no. For example, I'll give you an example. For airline reservation systems, we're taking a very large corpus of data, and then everybody's hitting that same data. You can browse it, and that's easy to do. And then you want to suddenly say, I want to reserve. And now you got to make sure that the possible 10,000 people looking at the same record all have to sort of agree, yes, this is reserved, and for that one. You'll end up needing an architecture very much like the hardware architecture of a mainframe. Mm-hmm. And I come down to, for example, database and ERP and big data workloads. They don't tend to be highly distributed. They tend to be, you have a lot of data, and you need to look at all of the data, so you need to move it from your storage system into compute, into main memory, and back out. So the kind of bandwidth, not just the pure flops or compute is important, but the bandwidth of moving stuff back and forth becomes critical.
Sure.
So when you look at that, there's a technology argument that's going to get made. Then you say somebody's written something that's tested, that works in AIX. Could be your Oracle database, could be your IBM database,
sure.
Could be your SAP systems or some other ERP, is already running against this. I've tested it. I know it scales. I get the latency. I get the response time that I need. Is there value to me to spend that much human labor to move it to a different system? Or should I keep that where it is, but I have a new application coming on. I'm doing a new mobile application. I got to have people coming on to come maybe browse from a new app that I released for the iPhone. What's the correct infrastructure for that? Because that tends to be lots of little workload.
Sure.
It comes, it goes, it comes, it goes. And you can then make the correct decision on that one. Should I keep it on this system or on that system? So I'm making a technology argument first. You got to pass, I can do it.
Sure.
Once you can do it, then you should look at the economics to decide what's the correct platform.
Which makes sense. What's the general roadmap for Power in terms of an architecture at this point?
So I won't refer to it as a Power 8, but let's talk about the kind of things that our engineers are working on and that you expect to see in some future releases. So, of course, as you go along in technology, you get more density. So you'll expect to get there is more compute per unit area coming up down the road. If you look at that roadmap, it's typically anywhere from 30 to 50% from generation to generation, and generations are typically about 2 or 3 years apart. Next, if you look at the kind of workloads that are now being supported, you could sort of go backwards by 30 years and say the workload was basically a very simple store, lookup kind of workload, and people kind of optimized to that. You go into the 80s and 90s, and people really did optimize architectures to worry about relational databases, etc., where you do worry uniquely about what instruction sets as well as what kind of I/O you need for those workloads. You then go forward to web workloads, and then you begin to worry about things like encryption, security, SSL, as well as TCP/IP, and you really do optimize architectures for those workloads. You come today, and now you say people are worrying about big data, social, mobile. What does this mean? You now got to worry about scripting languages. You got to worry about no longer tens of thousands of connections coming in, but perhaps millions coming in and out. So so the implications are, what's your threading model? Your implications are, how good are you at interpreted languages as opposed to compiled languages? Here, the questions become, how good are you at supporting lots and lots of parallel or pipeline workloads and be able to switch between them because you have lots of... So I'd assert that you expect to see in the next generation that you have systems that are the best for, in the end, to make it simple, big data and cloud workloads. And we'll be able to quantify that as these systems come out.
And then just from a competitive perspective, because your friends, peers, competitors, cooperators sometimes at Oracle love to compare Power versus Spark architecture. How do you see the two shaping up? And is it a speed versus feed contest, or is that not what the discussion should be about?
I don't know. It's like comparing. Do you remember a car called the Yugo that was brought in here?
Sure, Eastern
The
European.
Yeah. So I'd compare Spock to the Yugo, and I'd
Okay.
compare power to pick your mainstream. I mean,
Okay.
is it a Toyota, GM,
Sure.
Mercedes, depending on, are you going for volume or are you going for size?
Sure.
I mean, with Spock, so let's see. So if they really believed in Spock, the box they talk the most about is the Exadata box. Is that a fair assertion?
Yeah.
Well, why the hell is Exadata on x86? So I call it like I see it.
Yeah.
So that means to me that they don't themselves believe in Spock.
Sure.
Otherwise, they would build their premium box on Spock.
Sure. Well, they do have, to be fair, they do have the, what do they call it, the Spark supercluster, though that's not one of their engineered systems. It's general purpose
I
stuff.
got it. That's why I just pointed out when you see dissonance as a fact,
Yeah.
then I'd say that the words and the pictures are out of sync.
Yeah.
So I don't think that Spock is a viable architecture going forward,
Okay.
personally. I think that there's a few people with stuff running on Spock, back to my point on porting, so it'll be a slow decline, but it's a decline nevertheless on Spock.
Conference. What do you see as the big challenges, if any, that remain for Linux on Intel on IBM architectures, whether it's power or volume architectures?
I think it all becomes about proving that the management is straightforward and simple, and you can begin to run clusters of tens, hundreds, and thousands of these instances
Yeah.
at the correct economic benefit. What people are all looking for is nimbleness as well as cost of efficacy in operations.
Yeah.
I mean, we all talk about the statistic, right? 60 to 70% of most enterprises' budget is spent on operations of existing, not new. If you can lower that, that gives you more money for innovation. What Linux and our architecture has to do is to help you go lower that. You leverage more automation, leverage more standardization, leverage more of the resilience and capability of the architectures to sort of reduce the overall labor cost.